Here's another example of a hypothesis test for the population mean when the population standard deviation is unknown. A restaurant claims that the mean amount of time their customers wait for service is less than 3.5 minutes. The Quality Assurance Department took a simple random sample of 10 wait times, and the results are given below. Assume that the wait times are normally distributed and use a significance level of 0.10 to test the restaurant's claim. The wait times are given in minutes. Okay, let's record some of the information we have. Primarily that, we'll put that over here, we have a sample size of 10 and our alpha is 0.10. And then we've been given the actual data. Okay, so our original claim is the claim made by the restaurant. We're testing the restaurant's claim. What were they claiming? In the first sentence it says that the mean amount of time their customers wait for service is less than 3.5 minutes. So the mean is less than 3.5 minutes. Okay, the competing claim is that the mean is greater than or equal to 3.5 minutes. It has to cover every other possibility. Null hypothesis, the mean is equal to 3.5 minutes. And the alternate hypothesis, well, the condition of equality is with the competing claim, so the alternate hypothesis corresponds to the original claim. The mean is less than 3.5 minutes. Okay, we'll have a critical value, a test statistic, p-value, and we'll use that information plus our decision diagram to make a decision. Okay, let's look at the decision diagram. Pull that up a little bit more. There we go. Okay, our mean here is 0, and the alternate hypothesis, the inequality is pointing to the left. We have a left-tailed test with an alpha of 0.10. Okay, to find that critical value where alpha is 0.10, we'll use our inverse t function or the tables in the back of the book. Enter area to the left. To the left of this point right here on our number line is 0.10 or 0.1, comma, now the degrees of freedom. Okay, we had a sample size of 10, so our degrees of freedom is equal to 10 minus 1 or 9, n minus 1. Okay, and using your function on your calculator or the table, you should get a t-value of negative 1.38. That's rounded to 2 decimal places. So we get a t of negative 1.38. Okay, to run our test now, we'll need to enter this data into a list. Stat, edit, and we'll put this in a list. Let's see if I can move this down. You won't be able to see the whole calculator, but that's okay. So we'll put it in list 2, say, just to do something different here. Okay, first data value is 1.94, enter, 4.61, 5.20, 5.2, 3.7, 1.99, 4.73, 1.69, 2.88, 3.32, and 2.39. That's my 10th value. Enter. Okay, now we're ready to run our test. Stat, tests, we're using the t-test, the student t, enter. This time we have data. Data. So enter and highlight that. Our mu sub 0 was 3.5 minutes. The restaurant's claiming 3.5 minutes. My data is in list 2, so I'm going to use the second key and come down here and indicate list 2. Frequency is always 1. Come down to indicate my alternate hypothesis. What type of test do I have? I have a left-tailed test, and then we'll calculate. Okay, here's our t-test statistic, negative 0.6317, so I would round that to negative 0.63. My p-value is 0.2716. Okay, we can see the sample mean here and the sample standard deviation. We weren't given this, we were just given the data, but it's available there if we should want to record that for anything. So, negative 0.63, 0.2716. Okay, let's get this on our diagram. Let's see, we didn't get our, let me get my critical value here. Forgot to label that, negative 1.38. Now we have a test statistic of negative 0.63, so that's going to be somewhere over here, maybe. And our p-value of 0.27, so that would be all this area here. And we see that our test statistic does not fall in the critical region. Our p-value of 0.2716 is not less than our alpha of 0.10, so our decision would be fail to reject the null hypothesis. Okay, and now we're ready to write our conclusion. Does the original claim contain the condition of equality? No, it does not. Did we reject the null hypothesis? No, we did not. So our conclusion begins, there is not sufficient evidence to support the claim. That the mean amount of time customers wait for service is less than 3.5 minutes. Okay, so thinking about that, we said that the mean, null hypothesis does not correspond to the original claim. Therefore, failing to reject the null hypothesis ends up saying that we don't have evidence to support the claim. If we can't reject the null hypothesis, then we do not have evidence to support the claim.